So we can try this configuration with a number of Kanban which is similar for workstation 1 to at least to the ones we had in our theoretical approach. And I leave it to you to run them all and check the values. I'm going to comment in here. And you will get a new line in our table, this last one. And we also increase the benefits as it was the case in previous occasions. And we still have a very good income, and we reduce the cost even a little bit more. We have reduced the width by means of reducing this number of Kanban, and we still have a very good service level, which is very close to the vicinities of the theoretical one. We have a weight reduction as we expected, and there's no way we could improve our system by reducing the number of Kanban in workstation 1 and 2, because we need at least one Kanban in every workstation. So we might try to reduce the number of Kanban in workstation 4, which is not the slowest, so it's the one that might have less Kanban, because if we reduce the number of Kanban in workstation 3, we might get into trouble. So we should start first with workstation 4. So, well, by the way, workstation 3 still is working 100% of the time, but you can check that with your simulation model. So after this analysis, we can see what happens if we try 1153. So we reduce into the number of Kanban on workstation 4. If you do that, and you run the experiment, you'll have that you have a benefit which is very close to the one we had before, and we have increased the cost a little bit. So that doesn't make much sense, because we go reducing the number of Kanban, so you expect to reduce the weight. Again, this is due to the randomness that it involves in this kind of models, and that comparison is not probably very valid, so we will need to run the model several times for each case and do a confidence interval and see if there is a significant difference between these two scenarios. Anyways, there's a typo there. The width slightly increases, sorry, but it's because of the reason I mentioned. And we might try to reduce again the number of Kanban in workstation 4 to check if that actually has an impact or not. So we may try to run this configuration, and if we do that, we get a new line, and in this case we have slighter value of the benefit. Again, we have a larger value of the working process, again due to the randomness effect as it happened before. Again, we need to run a large number of replications, but with this first analysis we don't know for sure if there's a great difference, so we might explore this possibility. And in the first approach to the problem, we might consider this as a good configuration. And again, workstation 3 is our bottleneck is still, and we're close to the service level estimate, and we might try to reduce the number of Kanban again in workstation 4. So we're going to try these configurations here, 1143 and 22, which is what we have here. We have new lines. We still have one Kanban for workstation 1 and 2, and we're trying to reduce. Sorry, there was a typo there in the previous line. We're reducing the number of Kanban in workstation 3. So we have 1132 and 22, and we have a very good values for the benefit. We're reducing the width, at least in one of the cases, and we have a service level which is not bad. So that might be a bit might be a good configuration still. Okay, so we might try to go a step further and try to reduce the number of workstations in the only workstation where we can reduce them. And we might try this 1112 or 1121. And now we see there is an impact in our benefits. Okay, we have service levels which are worse enough so that the reduction in the weight, we have a reduction in costs, doesn't make up for the reduction in income. So we're losing more customers than, or the value of the customers we're losing doesn't make up for the cost we're saving in terms of weight. Okay, so according to this, we have some configurations here which we should explore in more detail. Okay, So these are not very distinguishable from one another. This where we have a benefit of 30, with this where we have 29.5. So we might need to explore this in detail, but we see that the values we had theoretically obtained are not exactly the same, although they are very similar to what we had. But in one of the cases where we have a high value of the security factor. So the good thing about using the simulation model is that you can actually not rely on a factor which doesn't explain much, but the fact that you have a buffer there for things that might happen. But actually you can try with a model that reproduces in a very detailed way what happens in the system, and you can actually make better decisions. And finally, I just wanted to comment that there's a module in Simio, as in other languages for simulation, where you can run experimentations such as the ones I'm showing here. You can define a scenario, and you can configure the number of Kanban, as you can see here, and you get results as the ones you have in this second image. And in this case, you have average values for the set of replications. In this case, I've run 10 replications for every experiment, and then you wouldn't have those counterintuitive effects that we checked that might show up. And in addition to that, for every scenario and all the output values you're interested in, you might have an average value, and a minimum, a maximum, and a half-width for a confidence interval that gives you more information than a single estimate, just a point which the better estimate for the average behavior of whatever you're watching as an input. Okay, so I hope this gives you a clear idea of how to use a simulation model to analyze a system, and in particular gives you ideas about how to analyze the problem with the Kanban system. I'll give you some details about the analysis you have to perform using this model to extend it and answer some situations, or give some answer to some situations with the customer. We have with a system like this for which you want to provide value using this simulation model. Thank you.